Welcome to qnawire.
In this situation, we have a hand-built vehicle that moves once a weight attached to a pulley falls. Now this weight unwinds a string that is wrapped around the axle of this vehicle. Now, if we look at the situation, a force has to be applied in order for the car to move. Now what's happening is there is an impulse present. So because there is an impulse present, we need to calculate that out. Now impulse can be calculated two ways. You've got force multiplied by the time period over which that force is applied, and you have a change in speed from an external presence. Now, in this situation, we can't do force times a change in time because we don't know how much force was actually applied here. We do, however, know that we had a final speed and a mass. So let's calculate it out using this method right here. The mass of the object is 6 kilograms, and that's multiplied by the change in speed. So the final speed is 3I, and the initial speed was 0 because it was at rest. So all you have to do here is 6 times 3 minus 6 times 0, which gives us 18 meters per, or kilograms meters per second. So that is the amount of impulse given by the floor. So does the work, or does the floor do any work on the vehicle? The answer there is no. Energy is not provided by the floor itself. The energy is provided from the object's gravitational potential energy turning into kinetic energy. So the floor itself doesn't actually do any work on the vehicle. We said in part A that the impulse came from the floor because of the external friction force. Now, because the impulse came from the floor, that means that the change in momentum had to come from that as well. The final momentum must have also come from the floor. Now, part B said that there was no work done by the floor, and that means that there cannot be any kinetic energy done from the floor either. So the kinetic energy actually comes from the gravitational potential energy provided by the mass at the end of the pulley changing from a high position to a low position, and that in turn allows our objects to move forward. So the change in energy, the work done, and also the increase in kinetic energy comes from the gravitational potential energy stored in the mass initially. Now the force allowing the object to move is of course a friction force. Now this friction force is static friction initially because it is not moving, but once that static friction is overcome, it turns into kinetic friction. The friction acting on the wheels allows it to go forward and not roll in place. The friction allows us to move forward with no slipping. So it's because of friction that the object is moving. That's the external force, but it is the gravitational potential energy allowing the energy to increase. So here's the answer from B through E summarized.